squared minus 32.
Okay. I'm going to zoom in here because I could probably use a little bit more room. Okay. So I see...
Oh, they're completely different things.
Yeah, but you still got a number in common, right? This is very similar to... you still have a number there, right? So you could deal with the number. You could factor it out, right? So 8 goes into 32 4 times. So I could take out 8. Oh, my goodness. This isn't working very nice when you zoom in, right? So that's also not very nice. What's going on here? It's too far zoomed in or what?
Wow. Zoomed in pretty big.
Okay.
That works.
So if I take out the 8, right? What's that leave me with?
Here, I'm just gonna... So, 8 a squared minus 4b squared.
Yeah. So you were right earlier when you said this is a difference of squares question, but it wasn't in its current state.
Yeah.
Right? But now you can square root the first, right? This is how difference of squares works. Square root the first, square root the last, right? Those are going to be the first two pieces. So I'm going to get 8a minus 2b. And then on the other side, see how I have no terms in the middle? So I don't have like any AB terms. There's no AB terms, right? So that must mean that they have to have canceled out, right? And for them to have canceled out, the only way they can cancel...
So you can just square root and get rid of the square roots? Or the 2's?
Yeah, I'm not done yet. I got one more thing to write here. I'm just trying to figure this out. So there's no AB terms, right? So then this one... This is what's called difference of squares. Right? I see a difference of 2 squares. This follows this pattern every single time you notice that. One is minus, one is plus. That's the answer done. Right? Every time. That only occurs because of the minus in the middle. You see how, like, if I were to expand this, do you see what I mean by the purple in the middle? How I don't see 2 in it? So if I expanded this, I would have gotten a negative 2BA. And then I would have gotten, if I expanded this one, that would have given me a plus a 2BA.
Mm-hmm.
So then they would have canceled, right?
Yeah.
So they don't appear in the middle. That's how I know that these signs have to be opposite. That make sense?
Yeah.
Good.
So we just square root. And then it's suddenly 8 bracket a minus 2b a plus 2b. It's just like, yeah, I know.
That's difference of squares.
I know this stuff.
Do you want to jump up to B?
That's just completed now?
That's it. Done. Sorted. That's your answer.
Okay, I'm just going to write a little note on difference of squares.
Okay.
No, I won't. I'll just say that this is distance of squares. Okay, difference of squares. Now, we're going to B?
We can do B real quick.
Sure.
So this is, this typically comes out of when you do not distribution, where you break down the middle term.
Oh, yeah.
Right? You get results, resulted with, see how there's an x minus 2 in both pieces? See how I say x minus 2 in both spots?
Mm-hmm.
Okay. Well, here's one piece, and here's the second piece, right? I see that I have something in common in both pieces. much like I saw the fact that I had an 8 in common amongst these two pieces. So then I can just take the purple, or the x minus 2's, and factor them out. Right? I have two pieces with a shared piece, or two pieces with something shared between them. So then I could just go, okay, well, I'm going to take the x minus 2's and factor them out. Take them. So then it's going to go x minus 2. And what's left after if I got rid of the x minus 2's? What's left?
3x minus 8.
Perfect. Right? That's it done. Make sense?
One, yeah.
I can put some equal signs in there too.
And then we have...
You see any other?
X minus 2, 3x minus 8.
Yep.
It's pretty easy.
Okay, what's next? Which one do you want to do?
Let's do H.
H. Okay. So this one,
It's pretty easy. It's just man, right?
it's just man, but I always, what's the first thing you always check for? Just so
If
we're
you
on the
can
same.
make the first thing 0, so it's just
Or 1.
1,
right?
yeah.
So you mean by it, or make it simple. It doesn't have to be 1. Like I just necessarily don't want to have to find two multiples of whatever 16 times 9 is and add
Yeah.
24, right? So if there's a way to simplify that with finding the greatest common factor, then I would do that first, right? I don't think there's a number that can go into 16, 24, and 9, right? 2 was close, but then you got to the 9, and you can't divide 9 by 2. So you're stuck, right? You gotta find, okay, so I need two numbers to multiply. Multiply to, what's 16 times 9? Oh boy.
144.
Oh, perfect. That's easy.
Yeah.
This is an easy one then.
Yes, sir.
Multiply to 144, add to 24. Right? I know, and you know, if you know your multiplication tables, that 12 and 12 satisfy those two scenarios,
Yes.
right? 12 and 12 give me 144 if you multiply them, and they add the two. There's something else going on here. I'll show you. That I only see now. Now that I've seen the answer. 12 and 12, right? So your answer is going to be this. So I'll show you this question in two different ways.
What?
Well, the answer kind of sucks this way. Because you know how, like, remember I showed you the table method, if we were to do it this way? Remember what I was showing you? You'd fill it in with the first term. This is good practice. We'll do it this way, and then I'll show you what I caught after the fact, right? Which we should have noticed from the beginning, and we didn't. So you could put in 16x squared here, right? And then you put the last term down in the bottom right.
Yeah.
Right? And then you break up the middle term with the two numbers that you found, right? And this works for any complex trinomial, right? So I could put 12x here and 12x here. And now your job is to read horizontally. You read horizontally and fill out the sides. You remember doing this? And then you can read vertically to fill at the top, right? So I see here, what's common between 12x and 9? 3.
3.
Right? And what's common between 16x squared and 12x?
4. Is it 4?
4x.
4x.
Because I see x squared and x between the terms, right?
Oh, yeah.
Right, so 4x. And then...
and then 16.
Now we got to do the vertical one now, right?
Yeah,
so
so
again, we're going to get 4x.
4x.
And 3.
Plus.
Right? So that means my answer is going to be 4x plus 3 multiplied by 4x plus 3. right? Which
Yeah.
condenses to 4x plus 3 squared. Right? Now, what we should have seen from the beginning, and I got prompted by once we had figured out what the two numbers were. Right? We should have seen this from the beginning, and we didn't. And this is something that you're gonna catch. You got to catch this on the test to save you time, right?
Okay.
So you see the 16x squared and the 9.
Yeah.
What's
3 goes into both of them.
well? Okay, so I can square root the first and square root the last. What's the square root of 16x squared?
4.
4x, right?
Oh, 4x. Yeah.
And what's the square root of the last one?
3. Well, at least we got an easy one that was just, we knew right off the bat it was 12, but...
Right? As soon as I saw that these two numbers were right, or the same, you can do this,
Yeah.
right? You don't even, like, if you recognize you can square root the first and square root the last, you can do this.
Yeah.
It's a perfect, we call those perfect square trinomials,
Yeah.
right?
Well,
That saves time.
yeah, it does. Okay.
We should have checked for that. I forgot about that. Okay, what's next? That was a good choice. H.
I'm just gonna start checking off the things we've done. So we've done B, E, H. Oh, bingo.
What's,
Want to do D?
yeah, that's a simple trinomial, right?
Yeah.
Good. So this one just straightforward. Find two numbers and multiply to 21. Add to 4. Sorry, negative 21. I missed the negative.
Minus 21. And then we just, man.
Yeah. So find the two numbers that satisfy both of those. And you can go through your numbers if you'd like. 1 and 21, not going to work.
7.
7 and 3, sorry,
Yeah.
is going to work, right?
Yeah.
7 and 3. But it has to be negative. How are you going to make it work? Make the 3 negative, right?
Yeah.
So once the 3 is negative, then you can go, okay, well, my answer is just going to be, I'm going to throw the variable, in this case x, in
Yeah.
front of those two numbers.
Yep.
So it's x plus 7 multiplied by x minus 3. And then you're done, right? And remember, I'm only allowed to do what I just did there with throwing the variable in front of those two numbers.
Yeah.
I'm only allowed to do that because this is 1,
Yeah.
right? If it's not 1, like it is if we jump over and do f,
Yeah.
right? You see that the number in front of x squared is not 1 anymore, right? So I'm not allowed to do that. I have to do the table
Okay. Yeah.
or decomposition,
Yeah.
one of the two, right? That was the word I was looking for earlier.
Decomposition.
Yeah. Okay.
Decomposition.
That's where you break up the middle term with the two numbers.
Are there going to be any questions where decomposition is necessary, or will I always?
Unless they specify that you have to do it with decomposition, I think you're fine.
Let's brush up on my decomposition.
I would, I don't think you need. I think this is perfectly fine.
Okay.
You use a table. I think it's easy, and I was like, when I saw that I was like, makes things 10 times easier,
Yeah, it's great.
right? Did you want to do? What do you want to do?
I feel like let's just do this one, just because it looks daunting.
All right.
But I'm sure it's gonna be pretty easy, I think.
Okay, so you just got to find what's. So again, this isn't much different than earlier when we did the exponents. I see numbers. I see p's.
Oh, Q5.
Right? And I see q's, right? Right? So find what's common amongst them. Right?
Mm-hmm. So, 20 minus 15.
No, okay, so careful. So you get a factor this time. It's not like it's not like a exponent question, but it is and it isn't, right? So you got to find a number. What can go both into
5.
Yeah, so pull out a 5, right? And your job is going to be to write whatever's left after you pull everything out, right? Whatever's a common, right?
4.
5. Well, we got to pull out the red. Just one sec. So do you see the yellows? I also see some yellow stuff that I could pull out, right?
Yeah.
So I could pull out p squared, right?
Yep.
So I could go 5p squared, right?
Oh, I see what you're doing.
And I can also pull out the p5 as well.
Yeah.
Or q5, sorry.
Yeah, Q7.
Q5.
Oh, yeah.
I can't pull out
yeah.
q, yeah. Just whatever the biggest exponent is, right?
5 p squared Q7 bracket. Oh, Q5, sorry.
Yeah.
Why do I keep doing that?
That's because it's on the other side there. And then your job is to write what's left after you pull that out.
So that's
So
going to be
5 goes into 20.
4 times.
You pulled out the p squared, so it's not there anymore. And you pulled out the q5, so it's also not there.
So 4 minus.
4 minus
3.
3 p
And then Q2.
q2.
Squared.
That's it, buddy. Done.
Perfect. Oh. End bracket.
You want? Let's jump down to G.
Okay. G.
What's special about G?
I have no idea.
I forgot to mention one other thing earlier, but
Okay.
what specifically? Let's look at G.
Okay.
What do you notice about this term and this term?
I don't know.
Okay, what do we do here?
Oh, is it a perfect square?
It is a perfect square trinomial.
Oh.
Square root the first. This is how this works, okay?
Okay.
Square root the first one.
Oh.
Square root the first, square root the last, and take the sign from B is the piece I forgot to mention earlier. So you're going to take the sign, whatever the sign is on B, you're going to put in between the two square root answers, right? I forgot to mention that over here, 4x plus 3. The plus came from the plus 24, right? So your answer, 5x and 1, take the sign from B, minus squared. Look how much time that's it. You could have gone through the man. See how much time that saved you?
Yeah.
It's 100% about recognition. Right? So it's 5x minus 1 squared. Okay?
So 5 minus 1.
X, don't forget the x.
5x minus
Right? Because you had x squared on there.
Yeah. So
And then there's 2 of them. This is a perfect square trinomial.
So squared?
Yeah. So 5x minus 1 squared is the answer. Okay?
Perfect.
Okay? Now, we can do C if you want. We can just finish this off and then you're done.
Yeah.
You seem pretty good with factoring, but let's... I need 2 numbers to multiply 28, add 2, 11.
So just new page. So we're doing C. Let me write down the question. N. So n squared plus 11. So 2 numbers that add to 11 and multiply to 28.
Yes. 128 is not going to work. 214 is not going to work. So that's 3. 3 doesn't go into 28. 4. 4 goes in 6. Nope. 7 times. Does that work? 7 and 4?
7 and 4 is 4. Yeah. 28. No, it's 28. Oh, yeah, that's it.
Right?
Yeah.
Okay, so the two numbers are 7 and 4. And do I see a 1 in front of n squared?
No.
But?
So we can just write the things down. What? Wait, what did you say?
Is there a
yeah,
1
you
there?
did,
Yeah, there is, right? Right, so they're both plus. So I can just write down it's equal to...
7 plus a.
Oh, yeah, just remember what the variable is. It's n in this question.
Oh, yes.
So it's n plus 7. It always goes on the left.
Yeah.
The left for simple trinomials. N plus 4 is your answer. That again, that only works because of the 1. Right? Next one, F. You can rip through these pretty good now. I don't see anything in common amongst these three terms, so you're stuck. What are you doing? You're doing man method. So two numbers that multiply to 12, right? Add to -8, and then you're going to find those two numbers. Okay.
3 times 8 is 24. Right? Yes.
Do I need it to be 24 though?
No.
What do you need
Oh,
to do?
4. 3 times 4, so it's 12. And then -8. So multiplies to 12 and adds to 4. 4 and 3? No.
It's a tricky one. Make you think.
6 and 2.
Both are negative, right?
Yeah.
Because they have to add to a -8.
Yes. Yeah.
Good. Okay. Now, you're going to draw the table now,
Okay.
right? Because no longer is this a simple trinomial like the last one, because I have a 3 out front, right?
Yeah.
So you're stuck. You have to use the decomposition or your table method, right? And actually, table method will work always, regardless. So if you are stuck, like, I'm just trying to save you time on the test, right? So if you see the 1, you can just write it out. If you don't have a 1, you have to use table. So now you just read. Okay, yeah, no, it's okay. You drew your table a little differently, but it doesn't matter. We're going to get the same answer.
Okay.
So I'm going to read horizontally, and I'm going to read vertically, factor out what's common, and then I'm going to express my final answer, right? So horizontally, I'm going to get, change the color, -2, and then, whoa, careful. Careful. We learned this. I remember when I started this with you and I didn't know it. Yeah, good. So the only time you can factor out a negative is when both things are negative, right? I forgot about that. So then I'm gonna get an x here and 2. So your answer should be what?
3x plus 2 and x plus 2.
Good, buddy. Okay, one more.
Okay. I'll check them out. So 6x squared.
15, 45, 90. Two numbers that multiply to 90. Add to -19. Oof, that's a good one.
8.
No, it's not even that bad. What are they?
9 and 10.
Yeah. Both have to be negative because they have to add, right? -9, -10. Let's do the table. Ooh, didn't like that. That's weird. Okay. Then I get 6x squared here, 15, -9x, and 10x. Okay. Read what's common. Five, 3x. And you get 2x. And I'm going to get 3 here. Did you already finish?
Oh, no. I was
Oh, I thought you'd
deep
finished
into the
before.